everyone. Welcome. Happy Friday. I am so glad to be here with you all. My name is Soleil Estevez, and I'm part of the public programs team here at the museum. And I'm just so excited today to talk with all of you about seasons. We are joined today by three very special guests and experts to talk just about that. Hi, Jackie. Hi, Daniella. They're going to be with you in just a second to talk all about the reasons for the seasons and why they matter. And we also have Deion here. Hi, Deion. Who is going to be piloting us through our YouTube spaceship or with our YouTube spaceship through OpenSpace, which is a tremendously powerful visualization tool that allows us to explore the universe in ways just like this. And so we're so excited to share all that with you in a second. Just a few quick reminders. We want to hear your questions. So let us know what your questions might be in the live chat. And we will be able to bring them up throughout the presentation and get them answered by our experts. And why don't we start with a question for you guys and let us know where you're tuning in from. Specifically today, because where you are in the world really affects how you might experience the seasons. So it's really interesting to see where you're all tuning from. And with that, I think that's a great segue into what we're talking about today, Jackie and Daniella. Why do we care? Why are seasons important? And why is it important to talk about them now?
Yeah, Soleil, thanks. I also want to make sure everybody knows today is Soleil's last day with us in the public programs department. We are very sad, but this is also your chance in the live comments to say goodbye to Soleil. You won't stop seeing her, but it is important for people to know she's done a tremendous job getting our virtual programming done during this difficult time with the pandemic. So Soleil, I'm going to say thank you again at the end, but thank you at the beginning too.
Thank you, Jackie.
But so launching into seasons, you've got me here, Daniella here, and Deion here, and we have different views of the seasons a little bit. At least Deion and I are native to this area. You will find out that Daniella is from a different area of the world, and that will be important. Actually, Daniella, why don't you tell us, where are you from?
Sure. Hi, everyone. It's so nice to be here. And as Jackie and Soleil said, my name is Daniella, and I'm originally from Lima, Peru, and that's in the Southern Hemisphere.
And Daniella is working with me now as she's an astrophysicist, as a postdoctoral fellow at the museum, an expert on many objects, but right now she's an expert on Southern Hemisphere, is where we're going to use you the most.
Sounds good.
Deion, you teach this in school, right? Seasons?
Oh, absolutely. It's a big part of the earth science curriculum, just seeing the reasons behind the seasons.
And Deion is an earth science teacher in Brooklyn at Eagle Academy. So he is also an expert for us.
Yeah, shout out to all the students who are logging in right now. You know what it is, Brooklyn. We're heading right into the fall in this northern hemisphere.
We're in the fall, right? And we've had these like great videos playing, but because we are in New York, all four of us right now, let's see that image, Soleil, because the question is, what are the seasons right now? This image just makes me so happy to see. You've got a view in Central Park, our great giant park in the middle of Manhattan, and you've got 4 different seasons being shown. On the upper left, you've got spring. On the bottom, it looks like fall. Upper right is the summer, and then the bottom right is the winter. You're seeing all of the different faces of what might happen in the exact same location, depending on the time of year. So from this perspective, seasons, as you may have existed in and lived in if you're in this area, are a change in the temperature. It's a change in the look of the landscape around you. And what's important to understand about seasons and planets and understanding our place in the universe and life is that seasons are critical to how we live on this planet. So Soleil's also got a number of images that we'll talk to you guys about now, because the thing about seasons is that they drive life cycles. This is an awesome picture of some birds migrating. I've certainly seen this. Have you guys seen a lot of birds migrating, especially right now?
Yeah.
This is migratory time. Yeah. This is what happens at this time of year, where it's getting colder on our side, very northern hemisphere centric right now. For those of us in New York, it's getting colder. The animals follow the temperatures. We've got some geese here. so they can keep them all. This is so cute. A little chipmunk hibernating. Animals take on different aspects of what's going on in the planet. And then as different cycles happen in spring, life follows that. Life very much follows the cycles in the temperature on the planet. Now you're seeing animals coming back to life after maybe hibernating, having babies. I think our next picture is some butterflies having a lovely time together. As there's the cycle of life follows the seasons. And the other thing is food follows the seasons. These are some apples that everybody's out apple picking right now in the Northern Hemisphere, and pumpkins. We know that you don't get these year round here in the Northern Hemisphere in the New York area. They're not grown all year round. And Daniella, you've got cases of this in the Southern Hemisphere too, right?
Yeah, I remember, I mean, most of my life I lived in Lima in Peru, and I always remember how strawberries were definitely a seasonal fruit. So you get in our winter.
There's a seasonality to all of this, to when you can get certain foods on this planet. So we can keep going through there's some more here. We've got tomatoes. They're big here in the summer in the Northern Hemisphere in the New York area. And all sorts of aspects of our eating lives are driven by what's fresh, what's coming straight from the farm. And that is fully driven by these seasons. So that's what they are. And that's what they do for us on this planet. They drive life. They drive all aspects of our life. And the question that we're going to answer for you guys today by flying around into this software is, why do we have them? Why do we have seasons? And do other places in the solar system have seasons? So let's jump right into it. We're going to switch into OpenSpace, which Deion is a masterful pilot of. Beautiful. And we've brought up for you a three-dimensional model of New York City. Again, that's where all of us are. We recognize that many of you might be in different places, but that's where we all are right now. And so what we want to show you is one of the major tells of what is causing the seasons. And so we're going to set the sun, and I want you guys to use this as a lesson. This is like a go home and do your homework kind of thing. This is an assignment. See if you can tell where the sun is at sunset every day for a year. All right, Deion's just set the sun, and let's pause as it sets. And Deion, what date were we at here?
This is September 22nd, 2021.
September 22nd, 2021. So that's basically first day of fall. It's not too far away. It's kind of like a midpoint for us in the Northern Hemisphere, where we're transitioning between the two extreme seasons of winter, of summer and winter. And you can see just by eye, look at where the sun is and where it's setting right now. It kind of looks like it's in the middle of the city here, like Empire State Building is kind of fresh in the center there. That's the September 22nd date and where the sun would be. Now, you may have never noticed this, but we're going to change the time. We're going to change time now. We're going to go forward in time to another date. Deion, why don't we pick the date of December 20th, right?
I'm going for December 20th for sure. There you go. So that's December 20th at the same exact time that the sun was setting in September.
Where did the sun go?
Mm-hmm. We'll have to rewind time a little bit to see it up in the middle of the winter, or beginning of winter rather.
And now we're going to set it in winter. So you can see the sun's in a real different position. It's much further south of where we had seen it while it was setting for the fall day. And here it comes back into your view, and it is going to set. And we're going to pause it at kind of a similar position. And look at how much further south it is at the moment of sunset when it goes below your horizon. Your angle to looking at the sun is real different in the winter than it was in the fall. And let's just do one more date. Let's move forward in time. Actually, I guess it's backwards in time from this date, because we're going to go to June
20th.
Right. June 20th. Okay. And let's set the sun here and see where it's going to be. These are three very different dates for New York. And notice we're setting the sun. You can do this experiment yourself. you can go outside every day and just mark where the sun is as it sets. And right around there, way north of where it was in the fall. So again, something is different between the fall, the winter, and the summer. All three of those dates mean major moments for changing seasons. And the sun, as you look at it from your position, is in a very different spot. All of you can do this. Now, all of it is due to one thing, which is the reason we have seasons. And this is your test for seeing it. And that is, anybody can answer. Maybe we can throw this out to the chat. Do you know the answer to this?
And actually, before we reveal the answer, we have a question from the chat that I think might be where you're heading, potentially. I'm going to bring it up for you here. It's from I. Kastner. I don't really understand how a few hours of daylight changes the season when being millions of miles closer does not affect the Earth in the same way. And I'm wondering if that might have any relation to what you were just talking about.
Yeah, so we're going to get to this idea of the distance away a planet is from the sun. And what the question seems to be bearing on is whether or not your distance is what is the driver of the seasons. And what we want to make sure we get rid of for everybody on this call today is the very, very common misconception that that is the reason that you're either closer or farther away. It's actually not the reason. It all comes down to the tilt of the Earth. The Earth is tilted by 23.5 degrees relative to the orbit of all of the planets actually around the sun. And this is actually a really critical thing. And part of how I want to answer that is something that I kind of skipped over a second ago, which is you asked about distance close or farther away. Well, our first day of winter is, for us in the Northern Hemisphere, is December 20th, which is where we set the sun. Daniella, what is your first day of winter in the Southern Hemisphere?
It's sometime in June.
June 20th, right?
Yeah.
Total
I was
opposite.
thinking about December, and like that's actually the end of the school year.
So we have a picture too of the difference, right?
Mm-hmm.
So like we could switch over and show a picture difference. And this is how you can really tell that for the Earth, it is not the distance. Because on the exact same day, you can have winter for those of us that are in the Northern Hemisphere and summer for those that are in the Southern Hemisphere. So like Daniella, oh, we've got it, right?
Yeah.
Deion, what were you doing there?
So a couple winters ago, this was me in Vermont, not too far away from New York City, but this was in the middle of December, and we were going skiing. As you can see, I'm quite bundled up. If you can really see my face, you can see a little bit of misery because it was quite cold. And yeah, I don't know. There's just something about that winter atmosphere that just makes you really want to bundle up and go next to a campfire.
And then at the exact same moment, so the Earth is in the exact same position. Daniella, what was happening in the Southern Hemisphere?
Well, usually for Christmas, I go visit my families, and that's when I leave New York, and it's looking like that picture from Deion. And then I come to Peru, I get off the plane, and it's summer. It is the middle of the summer. Not the middle, sorry, it's the beginning of the summer. Yes, and so we typically go to the beach for New Year's, and we have a very different Christmas experience. It's not white, it's just very sunny and gorgeous.
So that's the best reminder we can give all of you. Every time you think it's the distance, remember that the day we're outside freezing in the winter, the way Deion just was, Daniella's on the beach celebrating with the sun out, and it's the exact same planet. It's something else, and that something else is the tilt. And let's show you the tilt. So we're going to fly away from the Earth here. We're going to fly away so that we get this bird's eye view of the planet, so we can explain what this tilt means. And Daniella, do you want to take a first grab at explaining this tilt of the planet?
Sure. So first of all, let's think about, there's no up and down in space, right? So what is a tilt? In what direction does it go? So if we think about the sun, there is a plane in which all of the planets were formed. and all of the planets in our solar system are kind of roughly in a plane. And you can tell that also because if you get lucky to see several planets at the same time on a given night, you'll see that they all form a line. So this is sort of this is a hint for us to tell that they're aligned in a plane. And so if we think about the sun, spinning on its axis, because the sun also rotates, and all the planets going around it on this plane, the planets themselves have also a spin axis, and they're not necessarily aligned with the sun. They're like a little offset. And for the Earth, that tilt is about 23.5 degrees.
So the view that Deion's brought up for us is there's the Earth, no clouds on, so we don't actually have the atmosphere on to distract you with like cloud patterns. And all of the lines that are running around are the orbits of all the planets around the sun that Daniella was just talking about. Now, Deion, let's bring up this cartoon axis. It's going to look like a pencil, and it's going to stick out of the planet, and it's going to represent the axis, like the way that you would grab a top to spin it, like something you did when you were a kid. You'd always spin it and then land it on the ground, and it would spin around an axis. That is our axis. And Daniella, you can really see here, right, the planet's orbits around the sun versus that pencil.
Yes, yeah.
So it's a real obvious tilt. And that tilt number is 23.5 degrees. So what we're going to do is we're going to turn time on. We're going to try and demonstrate to you what that looks like when we speed time up. So Deion's going to kind of pull away so that we get this view of just the Earth, the sun, and we're going to turn time up so that we can move the planet around the Earth, around the sun very quickly, and watch how it's going around. As we pull away, just to explain more of the lines, the strong blue line that you're seeing is the orbit of the Earth around the sun. That pinkish dot circle that's kind of going around the Earth there, that's the orbit of the moon. And then these other lines that you're seeing are the other planets. Mercury, Venus are the inner planets to the sun. The sun is the nice big light bulb there. And all of the planets, they're not orbiting erratically. They're in a plane around the sun. And we're going to increase, we're going to do something that is not scientific, or at least we need to explain it to you. We're going to make all the other planets disappear, and we're going to increase the size of the Earth, right, Deion? We're going to make it much bigger.
It is now 5,000 times bigger than it normally is. So please do not think the Earth is this big compared to the sun. This is a simulation.
And actually, while we're out here, it's important to also note that this orbit doesn't really look highly eccentric. It's nearly circular, right, Daniella, as you look at this?
Yeah, exactly. It's nearly circular. So again, the distance to the sun has nothing to do with the seasons.
Right. Okay, now Deion has started time, and as we're kind of going around, I think we're still pointed on the northern hemisphere, right, Deion? We've got the pencil sticking out.
See the pencil sticking out. So if I were to go perpendicular, you can see that tilt a little bit better.
There it is.
So you can, what happens during the summer for whatever hemisphere you're in, whether it's Daniella in the southern hemisphere or us in New York in the northern hemisphere, what's happening is you are getting a lot of direct light. Essentially, your part of the hemisphere is leaned in, pointed more towards the sun, and it is directly pointing at you like a flashlight directly in your eyeball. That is what the sun is doing. That is the way you are receiving that light from the sun. And don't worry about that darkness that kind of passes over the Earth there. This is just because we've scaled the Earth up to be so big. So as we're coming around, you can see now you're on one side of the sun, and the hemisphere that's pointed down towards the sun, it's getting the most direct light. The second half of the hemisphere there below the blue line is getting less direct light. So it would be winter there. Exact same day, you would be getting the majority of the direct light in your hemisphere, and the other hemisphere would be getting the opposite of what you're getting. So we're coming around. I hope people are getting this in the chat. So if anybody has any questions, you can bring them into us, because we all of us recognize Deion as a science teacher. Daniella and I, as astronomers, that this concept is not easy, right, guys?
Oh, not at all. It takes a while to really figure it out. So I just wanted to point something out while I was here.
Yep.
Right here is when the Earth is at December 21st, or around when we think is the peak of, or the start of winter. And for the Northern Hemisphere, that's pointing out this way. So we're on the Northern Hemisphere facing away from the sun. But if I were to switch it to June, that same year, now we're facing towards the sun. So even though we're spinning around that axis, we're getting a completely different amount of sunlight depending on our angle towards the sun.
It's all about whether you're leaned into the sun or leaning away from the sun. 23.5 degrees. Everything comes down to that number for us. Soleil, do you have a question?
I do. It's actually just a clarifying question about the planes of the orbits of the planet, and just this is from Jackie Ann, and I'll bring it up real quick. Just are all the planets on the same plane? Just again a clarifying question, and that might relate to whether maybe there's seasons on other planets too.
Yeah, Daniela, do you want to take that one since you started the answer on that one before?
Sure. The answer is yes. All of the planets are in the same plane, and that is a big clue to how they form. So we think that all the planets form, like when the star was very young, when the star was forming itself, if you can think of like a pizza that you're, trying to flatten from the dough ball, it will have like a little disc around, becomes a pizza, right? And that disc is due to what we call conservation of angular momentum. And all it's doing is that there's going to be material that is sort of perpendicular to where to the spin axis of the star. And so that's the plane where all the planets formed, or so we think.
And just as for this question for another Jackie, is that the planet that is off the plane the most is Pluto. It's off by a significant amount compared to the other planets. And we do have it. We can show it to you guys. I don't think you can do. Oh, there you go. So.
Oh, wow.
Pluto?
Yeah. That's Pluto.
Whoa.
So this is more evidence that we have that Pluto is a problematic object to call a planet, the way we call all of the other planets.
All the orbits align.
See how Pluto does that?
We're always picking on Pluto.
Sorry, Pluto fans. Right.
Just because it's not a planet doesn't make it special.
That's right. I always say that, I'd rather be the queen of the Kuiper Belt than, the joker of the planetary system. So, okay. But on to the next part of that question is, now, do other planets have seasons? AKA, because we've just told you that it's about the tilt. Do other planets have the kind of tilt that we do? And more than that, the second part, it is all about the tilt. Tilt, tilt, tilt. Never forget, 23.5 degrees, tilt is everything. The other thing is the atmosphere. We need an atmosphere to hold on to that heat, to hold on to the energy that you're going to have as changing throughout the year. So atmosphere and tilt. But let's actually show this video, Soleil, that you have. It's a fantastic video animation made by James O'Donoghue, who works for NASA. And this is demonstrating for you the tilts of all of the planets in the solar system, including Pluto, and some dwarf planets like Ceres, which is a dwarf planet. Now note Earth, 23.5 degree tilt from the plane where all of the planets are. And Mars, look at Mars. Mars is a lot like us. And check out Mercury and Venus and Ceres and Jupiter and how different they are. Now we're going to go to one of these. We're going to go to a couple of these, but the question is for you guys, do you think these other planets have seasons based on what we've said to you? So the first one we'll go to is Mars. First, look at Mars here. Check out Mars and then answer in the chat. What do you guys think? Does Mars have seasons? Do you think Mars has seasons? You can answer any way you like. And then we're going to fly to Mars and we're going to talk about it. So why don't we head there? Daniela, what do you think?
Well, you just showed us the like all the tilts up from the planets, right? And Mars actually looks very similar to Earth. So my guess is yes.
Yeah, right. We kind of know the answer because we are astronomers. But
and I can tell from the chat that we're also getting a lot of yeses in there.
Nice.
Good.
And as we come in, Deion has brought us in. Deion, what are the lines going around Mars here?
Each of those lines represent one of the moons of Mars. So there's 2 of them, right?
Yeah, Mars has 2 moons. They're called Phobos and Deimos. And just by looking at the moons and how they're orbiting Mars relative to that kind of the background that you're seeing still of all of the orbits of the other planets in the solar system, which mark the plane, you can see that Mars is tilted. And that tilt is the same as the pencil. It's off by just a little bit, 25 degrees for Mars, 23 and a half degrees for us. But it's tilted, and Mars has that other ingredient, which is an atmosphere. It's a lighter atmosphere than we have, but it does have an atmosphere. And so Mars has seasons for sure. Mars does have seasons. Its seasons are much longer than ours, in part because it takes it twice as long to go around the sun than it does take us because it's farther away from the sun. But it does have seasons. It's covered in dust. It doesn't have oceans the way that we do. And so the impact of having the seasons will look differently on Mars. Dust storms will be part of what is raging on the planet on one hemisphere versus the other, as opposed to on Earth, we get very, very strong weather-related phenomenon that have more to do with clouds and weather and whatnot. And so differing in that way. Question, Soleil? Do you have a question?
We have some good questions, but I think I might save them to the end because they're back on Earth.
Okay, we'll save the questions for Earth. Now let's talk about some other planets. Can we bring back up that video, Soleil, of all of the planets? Okay, now Danielle, I'll let you pick the next one we do.
I'm gonna go with Uranus.
Uranus.
Yeah.
Do you
So
guys
Uranus
think
looks really
Uranus?
crazy. That's a 98-degree almost tilt. Look, it's like pointing perpendicular almost. So then this means that Uranus, when it orbits around the sun, its spin axis is rotating sideways. And we know that the planets form together because they're on a plane, as we said, but this thing is rotating in a very different direction. So it could have been a result of a collision, and it just like knocked the planet on its side, and now it's just going sideways. But then, why do people think does Uranus have seasons?
You can take
Let
your
us know
time and
in the
answer
chat.
that in the chat. Yeah.
I'll let you know what they say when the results come in.
Right.
And then Deion's going to fly us to Uranus.
And in the meantime, I'll say that Uranus is really far away. It's about 20 times as far as the Earth is from the sun. So its year, so a whole orbit around the sun takes 84 Earth years. So that's very long. You only get a birthday every 84 years. So what are the results coming in, Soleil? What do people think about Uranus?
I think we're stumping them. I'm not sure. I think they're completely stumped on this one.
is
I haven't
very
got any
weird.
responses yet.
Yeah.
Oh, here they come in. 1 no and 2 yeses. So again,
Interesting.
I think we might have stumped with this planet. So what do you think?
So thanks, Deion, for showing the moons of Uranus, and you can really see how it is completely tilted. But the whole point is that the tilts causes the seasons, right? So then, yes, Uranus has seasons. They're just very different from what Earth seasons are like. The whole orbit lasts like 84 years. So like every season's probably more like 20 something years. But then as Uranus is moving around the sun, is the same. There you go. The same face is looking at the sun every time. So Uranus is so far away anyway that the seasons are all going to be cold. But it does have an atmosphere, although it's composed mostly of hydrogen and helium and a little bit of methane. It's not a very pleasant place to smell, but the seasons are going to be much longer. Each season is going to be 20 years. And the seasons are going to be, all of them are going to be very cold because either way, the orbit is very long from the sun. Is there something else you want to add about Uranus, Jackie, that I'm missing?
I think that I love watching Uranus. I don't know if everybody else does because of that tilt, and seeing those moons orbit it that well really teaches you some lessons on the dynamics of solar systems. But It is everything you've said is spot on. It has the atmosphere. It's got the tilt. Those are the two ingredients for the seasons there, but it is much farther away. And so it's real cold. And I just kind of want to bring us back to our thesis here on talking about life. And we started this with like life follows the patterns on other worlds. And that is a big question we have about other worlds. Everyone we've said though thus far, Mars, Uranus, none of them have life as we know it. But if they did, we'd also be talking about how these seasons might be affecting life on those worlds. So I want that to be a key. Remember, life follows the patterns of the seasons on our planet, and it would do so as well on these other worlds with their differing seasons if they had life on them. So let's talk about one last planet in our solar system. Let's bring that animation back up, Soleil, and let's talk about Venus. Look at Venus there. Venus is such a bizarre world.
Is it upside down?
Yeah, it is upside down, Soleil. Yep. It looks like something knocked it completely off its
Uranus.
And it rotates backwards relative to the other worlds, if you notice the arrow. The other thing is that Venus has a day that is longer than its year. It takes.
How can that be possible?
We don't know how it happened. I mean, it can just be possible. We just don't know how it happened. Wow. It just orbits so slowly on its axis that it would take the entire time it takes it to go around the sun to do one full day rotation that we would call a 24-hour day on our planet. So, and look at the tilt of Venus there. It has essentially 0 for all respective purposes. It's got a thick atmosphere. So the question for all of you now is, does Venus have seasons? What do you guys think? Does it have seasons? It's got an atmosphere.
Every day is your birthday.
Huh?
And every day is your birthday.
And every day, your birthday is literally the whole entire year.
So Venus orbits backwards. It's upside down. And a year is longer than a day?
Yeah, Venus is a really bizarre world.
Really bizarre.
Yeah. I mean, this figure tells you so many tales of what happened to the solar system. Yeah. I wish if spin axis orbit alignments could speak, they would tell us all about what happened to the solar system when it was born.
And again, I think we got another stumper. Just looking at the chat, we have an even split between yes for Venus seasons and no for Venus seasons. So I don't know. What do you tell us, Jackie?
Well, let's fly to Venus, and I will tell you guys that Venus doesn't have any moons to show you that it doesn't have a tilt. It actually has, which has always been an intriguing factor about Venus. It's very similar in size to Earth. No moons, nothing. Mars has 2, we have 1, Venus has nothing. We come in, it's a very cloudy world, super thick, toxic clouds that cover Venus, and but 0 tilt means no seasons. There are no seasons on Venus. Venus's full year, aka full day, is just hot. It is a hot, 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 hot world that stays hot all through its day year. So that's your answer. Venus, which is often called a twin to Earth, especially when we're talking about finding worlds beyond Earth, is nothing like us when it comes to seasons, nothing like us when it comes to the composition of the world. And so that's fascinating to think about. Life may have existed on Venus at some time, way back in the day, but nothing is there now. So we can't really talk about how even the non-existence of seasons would be affecting life on this world. And we're going to end on one last thought process, and that's we're talking about seasons. We're talking about the planets and how the signatures of formation and the spin at the way that they're tilted. But what about planets beyond our solar system? What about the worlds beyond? Let's get a little view, Deion, of the stars and take a second and reflect on this gorgeous view that OpenSpace gives us. So you're kind of bringing the Milky Way into view here. Oh, I saw the Scorpion just fly by, the constellation of the Scorpion. You can see the hook, it's coming in. There's Sagittarius to the left. There's a teapot there that you might be able to make out. And there's the whole solar system, the plane of the solar system here. And look at your stars everywhere. You should look at the stars every chance you get at night. Deion, why don't you pull up the locations of exoplanets? So Deion's going to highlight the locations of stars for which we have looked at them carefully and we know that they have a planet around them. So one of the questions that we ask is, could they have life on these worlds? What kind of worlds are they? If they do have life, do they have seasons that impact their life the way that life exists on this world? We're going to fly you to one, and it's called the TRAPPIST system. And as we fly to it, Daniella, why don't you tell us about this system, because you were actually on the discovery paper for this brand new system.
Yeah, sure. So I was part of a group of scientists who identified at first 3 planets around this very, very cold star. And then we realized there were 7. And this star that's like shaking there, ready to show us its planets. This is a very cold star. It has about 10% of the mass of the sun. So instead of being, so it becomes much, much colder, and it emits most of its light on redder wavelengths instead of like the whole white light that we see. So it's kind of a red, small, low mass star that was almost a brown dwarf. I'm sure you have heard that word since Jackie hosts these very often. But all of the planets around it are a little bit bigger and a little bit smaller than the Earth. And all of the orbits of these planets, all of them, 7 planets, they all fit inside the orbit of Mercury. It's like a very tight, scaled down version of, well, not quite our solar system, because this doesn't have any giant planets. But yeah, it's very unique. We haven't found anything like this after that even.
Yeah, so that's why you can see that Deion kind of zoomed in and you saw it's a red spotlight at the center of that. That's because it's a much cooler star than our own. And that green area that is marked off in here where the planets are kind of orbiting, and they orbit very fast around their host star, is the position of the habitable zone. And that's a zone where we believe that you could have the right amount of flux, the right amount of heat from the star, so that liquid water could bubble on the surface of the planet. And so if that were the case, you could imagine that there are worlds in here that may have a kind of atmosphere, possibly conditions that might be like our own on Earth. And so there's a lot of new science that revolves around studying these worlds. The second planet in there, the C planet, is and Deion has us moving on. Deion, how fast are we moving? I think you just told me in the chat.
Yeah, we're moving at about half a day every second. And
Wow.
so these planets are flying around this system.
That's right. Yeah. Mm-hmm. Yeah, these things, and that's actually how you can find them, because you don't have to stare at the star for too long and you see them dip the light. That's how they were found. The paper Daniella was just mentioning that she was a part of the discovery on. You saw the light of the star dim, 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 dim rapidly over a short amount of time. And that's because the planet passes between your eye and your telescope and the star. But so we're studying these worlds. And one of the things that we study is we study their atmospheres. You might study their angle, their axis, how they're spinning. And in that, we would learn if they have seasons. We would learn if they have seasonality. And so even as we're looking for biosignatures of life, we might also begin to ask the questions of how seasons might impact the life that exists on these worlds. So that's the last science thought we wanted to leave you guys with. That remember always, tilt, atmosphere, that tilt is 23.5 degrees. And it really, really sets the tone for life on this planet. And then the other thing is, remember, Daniella has winter when we have summer, and it's the exact same day.
That is a really great way to wrap up the presentation. And if you have a few extra minutes, we do have some really incredible questions that I think we can tackle quickly before signing off. The first is actually in our solar neighborhood. So yeah, Deion, if you want to fly us back to our neighboring planets, because we have from Beginner Crochet that their 4-year-old son is wondering if there might be tornadoes or sandstorms on other worlds?
Ooh.
That's a
And
good
I think it
question.
might be, right?
Yeah. Daniela, you want to take that one?
Only partially. But I think we expect them. We haven't really seen it outside of our solar system, but we know that there are these dust storms in Mars. We know about the Jupiter red spot. That's actually a giant storm. So we have some indications that, yeah, why not? I mean, this should be happening in other planets as well.
Yeah, we have no direct evidence yet for like a tornado. I want to say that, but then I want to actually back off that too, because we talk about the tornadoes are defined by material that's flying around, the wind speeds. And we do talk about wind speeds, how fast the air is moving, how fast the atmosphere is moving on other worlds. And those kinds of measurements do exist for worlds beyond our solar system. Actually, a postdoc in our group, another scientist that we work with, Johanna Voss, who's usually in the chat or has been in the chat. She was part of the very, very first ever extrasolar object outside of, our solar system that had a wind speed measured. And you can really compare how fast the air is moving on these other worlds. That's a thing that we can do right now. It's in your near future. Was it a young one who asked the question, Soleil?
Yes. He was 4, I believe. And I also think too, I don't know if we have time to show Jupiter, because I feel like Jupiter has a really big storm, right?
Yeah, we could show Jupiter. We can move to Jupiter and throw another question in too, so that we can
Absolutely. And I think this question is actually a great one. It comes from a 5th grade class. Thanks for tuning in. And quickly on that, if you are tuning in with your classroom right now, whether virtually or in school, hi, we love that you're here, and tell us your questions. Maybe your teacher can put in a question on behalf of the class in the chat, and we'll try to get them answered for you. But this question comes from a 5th grade class that would like to know, what would happen if the Earth just stopped spinning altogether?
If it happened where the Earth stopped spinning completely, like somebody hit the brakes, we would all fly off.
Yeah.
Would we really?
Oh, we would go flying. I mean, gravity would have
still moving.
Yeah, because we're flying through space at a very, very fast speed.
Yeah.
So we'd all go. You know how it's like when you're in a car and somebody hits the brakes. You slam on the brakes, you fly forward and hit your seatbelt.
Wow.
That is what would happen. The Earth moves very, very fast through space. We don't notice because we're all moving together. If you let yourself get too wrapped up in that, I think it's a crazy thought.
But if we were to take that question a different way too, and just say, what if the Earth was never spinning, but we had a tilt? Would we still have seasons?
If you're like living on Venus, right? Or
yeah, that's right.
Venus, I guess.
That's right. What the tilt does, and I don't know if we made this as clear, what the tilt does is it changes the amount of heat that you're getting. And that heat will move through the atmosphere. It gets absorbed by the ground. Remember, like in the summer, if you go with your bare feet on like pavement, it's so hot. Like there's a phrase like you could burn an egg on a sidewalk kind of idea in the summer. That doesn't happen in the winter, even on a sunny day. The point is you're getting a lot more heat that gets absorbed into the ground. It gets held onto. And so because of that, you will get a change in if the tilt is changing, that incident heat, the atmosphere absorbs it, the ground absorbs it. If it's the same throughout the year in every place on the planet, then you don't have seasons. Mm-hmm. You're seasonless.
Awesome. Thank you for answering that. And I think that is all the questions that we've had in the chat so far. And so I just, again, want to thank you all for tuning in to learn all about the reasons for the seasons and why the seasons are so important for life on Earth and for our potential discovery of life on other worlds. A few just housekeeping announcements before we sign off for today. Your feedback is incredibly important for us. So if you want to take the time to fill out a quick survey, we'll provide that link in the chat for you. And if you do fill out the survey, you'll get a free NASA sticker, which I know everyone here has. Jackie and I love our NASA stickers. There we go, Deion also. So definitely fill out that if you can. And also, specifically, if you are watching this with your class, if you're a part of a class, or if you're a teacher watching this with your class, please let us know in the chat or on the survey. We're trying to understand how these programs could be a resource for teachers in their classrooms. So just reach out to us so we can continue providing these for you now and in the future.
Thank you. And thank you, Soleil.
Thank you,
Daniella.
Soleil.
John, for
Soleil, this is your
amazing
last
presentation.
program. We've loved having you. Thank you, thank you, thank you.
My pleasure. And I'll see you guys later on a YouTube spaceship for future programs, but tuning in from YouTube. Bye, everyone.
Bye, everybody.
Bye.